langsung ini dibawakan khas kepada anda oleh Akademi YouTuber Malaysia. Tumpukan perhatian anda, siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good evening. Hi everyone. Hi teachers, parents and all students. Welcome to Pusat Tuisyen Academy YouTuber, a joint venture with e-Didik Malaysia and Kelab Guru Malaysia with the hashtag bermula percuma, selamanya percuma. Before we proceed, let's begin our session with the recitation of Kitab Al-Fatihah for the Muslim and a moment of silence for the non-Muslim. Al-Fatihah. For the record, so how's everyone today? My prayer that everyone is in the best of health and ready to proceed with today's class. Before we start, let me introduce myself first. My name is Nun binti Muhammad Nun. You can call me Madam Nun. I am lecturer from College Matrikulasi Negeri Sembilan. Today are very special because I am your moderator and also the presenter for today's class. For the record, we are now live on my channel. So as a sign of support to me, please subscribe my channel, yeah? And as usual, our class will last approximately 1 hour. The certificate link and the credit link will be given at the end of this session. Remember that you can only use e-Didik email to claim the certificate. For the credit claim, you need to collect one letter and for a 5-digit code, which will be announced separately during our class today. So be sure to follow the class up until the end to get the complete code for the credit claim. I would also like to remind all students, if you wish to post any comment in the chat box, please use appropriate language and use appropriate profile picture. I am pretty sure that all of you are excellent students who will uphold a positive classroom environment. Please give your full cooperation in making this class a lively one. Stay focused, and if you have any question, please write on the chat box and we will try to provide you with the answers. Okay, before we start, I will announce the code for the credit claim. So for the first letter and 2-digit code is A35. A35. Okay, so let's start. Okay, so before I proceed to the revision and exercise, I just want to introduce you in the academic YouTuber. We have the pre-U team, which is for the physics pre-U led by Madam Rosmaya. Okay, and then for the mathematics teams, it is led by Teacher Im. Sorry. Okay. So for the biology pre-U team led by Cikgu Faiza. And then for the chemistry team, led by Cikgu Shahnun. For the perakaunan and ekonomi pre-U team, led by Madam Fizi. And then academic YouTuber also have apps. So you can download from the Google Play, the apps, okay? And then you will get a lot of video, the academical video. And then you also can find a lot of video from many teachers, okay? All right, now we go to our purpose for today's class, which is revision and exercise for past year question. I will discuss the question from the mid-semester test for the work, energy, and power topic. Okay. So before we go to the exercise, okay, I have pasted the link at the chat box, the question link, so that if you want to try to answer the question, you can try to answer the question first. So before we go to the question, I just want to go through what you have learned in this topic. Okay, firstly, it is about work. Okay, the definition of work, which is work done by a constant force. It is defined as the scalar or dot product between the force and the displacement of a body. So given by the equation of W is equal to F dot S or Fs cos theta. The important is you understand that the F is the magnitude of force, the S is the displacement of the body, and theta is the angle between the force and the displacement. So make sure that you identify theta before when you want to substitute. Okay, and then instead of from this equation to calculate work done, we also can get the work done from the graph of force versus displacement. So referring to this graph, the area under the graph is represent the work done. And work is a scalar quantity with the unit of joules or Newton meter, or in the base SI unit, it is represented by kgm square as -2. And then the second part of this topic is about the energy. So for the energy, there are three types of energy that you're supposed to learn, which is the gravitational potential energy, which is U is equal to mgh. Gravitational potential energy is because of the position of the object. For the elastic potential energy, it is stored in the spring, and the kinetic energy is because of the motion of the object. And then relate to the energy, we have a principle of conservation of energy, which is state that in an isolated or closed system, the total energy of that system is constant. And we also have the principle of conservation of mechanical energy. And for the principle of conservation of mechanical energy state that in an isolated or closed system, total mechanical energy is constant. So when we talk about the mechanical energy, it is specific referring to the potential energy, either the gravitational or elastic potential energy, and also the kinetic energy. And lastly, we have the energy theorem, which is relate the work and the energy. So it states that the work done by the net force on the body equal to the change in body's kinetic energy. So for the matriculation level, we just focus on the change in body's kinetic energy. Okay, and the last part of this topic is about the power. So power is actually the rate of energy transfer. But in this subtopic, you will learn two types of power, which is you need to do the calculation for the average power, which is average power is defined as the rate at which work is done or the rate of total amount of energy transfer. Okay, given by this equation. And for the instantaneous power, the definition is it is the rate of energy transfer at any particular instance. That's why we call it instantaneous power. So referring to the equation of power, which is dW per dt, so we said that if an object move uh, a distance s at a constant force F, so we can write down the instantaneous power, which is equal to F dot V or FV cos theta. And power is also the scalar quantity, and the unit is watt or joule per second. Okay, now take a look at the exercise. If I'm not mistaken, I give you 15 exercise that we will discuss from the mid-semester test question. Okay, so take a look at question number 1. For question number 1, figure 1 shows a block of mass 60 kilogram pulled by a constant force F. 200 Newton on the rough surface at the angle of 47 degree to the horizontal. The frictional force between the block and the surface is 70 Newton. If the block moves 50 meter horizontally, determine the net work done on the block. So I have given the information from the question I have write down here. So that is easier for you. If you write down the information given, maybe when you want to substitute, it is quite easy lah for you to substitute the value. Okay. So how's the solution? Okay, take a look at the solution. First, because of, if you look at, there are because it is mentioned it is a rough surface and there is external forces exerted on the object, is the best thing is we sketch the free body diagram so that we can identify all the forces exerted on the object. In this case, because of we want to calculate the net force, so you need to know the net. We want to calculate the net work done, so you need to know the net forces exerted on the object. So because of that, if you refer to the free body diagram, the external force, okay, constant pulling force, which is 200 Newton force, is not located at the x or y component, so we need to resolve it. So referring to this part, to calculate the net work done, the equation is actually W net is equal to sum of forces exerted at the x component. Because of x component is same parallel to the motion, parallel to the displacement of the object times with the displacement. But if we look at the information given, we do not have the total forces at the x component. So what we need to do, we need to calculate first. So to calculate the total forces exerted at the x component, okay, referring to the free body diagram, we have F cos theta, which is to the right or same direction with the displacement or same direction with the acceleration, and the friction force at the x component, opposite direction. Because of that, when we substitute the value, we get that the sum of total forces at the x component is 66.4 Newton. Okay, and then from that value we can calculate the net force because of displacement is given, which is the block is moved 50 meter horizontally. Because of that, 66.4 times 50, the net work done on the block is equal to 3.32 kilojoule. So this is how we apply the free body diagram from the previous topic to calculate the net work done. It is related, so very important. For question number 2, figure 2 shows a graph of resultant force against displacement of a 8 kilogram trolley. So if you look at, there's only one information given, which is the mass of the trolley, 8 kilogram. We need to determine the total work done on the trolley. So in this case, because of the given the graph of F versus S, remember there are two ways to calculate the work done, from calculation and also from the graph. So if we refer to the graph, total work done is actually represented by the area under the graph, and referring to the graph, the area shape of the graph is the rectangle, so we can calculate the area under the graph, which is W, giving the total work done is equal to 31 times with 3 plus with 0, because of from 3 to 6 seconds, there is no forces exerted on the object. So the work done is equal to 93 joule. Okay, directly from the area under the graph, we get the total work done on the trolley. Okay, for question number 3, a 10 joule of work is needed to stretch an elastic spring by 2 centimeter. Calculate the work required to further extend the spring to 5 centimeter. Okay, so we need to calculate the work. So in this case, given the, I just write down that the work W1 is 10 joule. Because of with the 10 joule of work done, the spring will stretch to centimeter. And we want to calculate what is the work required to extend the spring until 5 centimeter. So what we need to do first, we know that the work done to stretching the spring is equal to the potential energy that's stored in the spring. So because of that, our work done is 10 joule, equal to, for the potential energy of the spring is equal to half k x square, half k x square. We can calculate the spring constant first, because in these two cases, the spring is, we use the same spring. So the k is same. From the calculation, we get the k, the spring constant, which is 50,000 Newton per meter. And after we get the k, now we can calculate the work done, or the work that required to extend the spring 5 centimeter by using the same equation. But now W is equal to half. Our K is that we have calculated here, and we substitute the extension of the spring, stretching of the spring. So the value is equal to, the work done is equal to 62.5 joule, meaning that 62.5 joule work required to extend the spring to 5 centimeter. Okay, So that's the solution for question number 3. So if you have any question, you can write down in the chat box. Okay, I will try to provide you the answer. Okay. Now we go to the question number 4. Okay, for question number 4, figure shows the variation between the applied force and compression of a spring. When the spring is compressed 0.2 meter, calculate the work done on the spring and also the potential energy. So first we want to calculate the work done on the spring because of this is the graph. All the information is from the graph. You can refer to the graph to get all the information. So in this case, if you want to calculate the work done on the spring, so same referring to the previous question, the work done is represent the area under the graph of F versus X. Okay. So because of that, we can calculate the work done. Okay, where the shape of the graph is represent the triangle. Because of that, we calculate the area of the triangle, which is half times 8 times with 0.2 meter. And you will get that the work done on the spring is 0.8 joule. Okay. And then for the potential energy of the spring, so potential energy that's stored in the spring is also equal to work done in compressing the spring. So work done to compress the spring to 0.2 meter is 0.8 joule. This is referring to the concept of work done and the potential energy that's stored in the spring. But if you want to do the calculation, if you're not sure that this is the concept, you also can calculate. So if you calculate, you will get that the U is equal to half Fx, and then F is referred to 8, or F is X, 8 Newton, and the compression is 0.2. Because of the 8 Newton forces, the spring compressed 0.2 meter. So you substitute, you also will get the same answer. Okay, so either one, you can mention that the potential energy in the spring is equal to the work done in compressing the spring. So the value is equal. But if you want to calculate, you also can. Okay. Now we go to the question number 5. Okay, if you think that I am too fast, you can write down in the chat box. Okay, or if okay, it is okay. So for question number 5, the mass of a carbon atom model is 20 gram. All right. And then A, we need to calculate the kinetic energy of the model moving with a speed of 2 meter per second. So we want to, if you look at the information given, because of the A, we want to calculate the kinetic energy. If the V is equal to 2 meter per second, so how we calculate? It is referring directly to the equation. Don't forget, the equation is given to you in the question paper. So K is equal to half mv square. You just need to substitute the mass of the carbon atom model and also the speed, which is 2 meter per second, and you will get the kinetic energy is equal to 0.04 joule. Okay, and then for B, two carbon atom model are joined by a spring. The energy of the spring is equal to the kinetic energy in part A. Okay, do take note, this is a very big information, meaning that the use in the spring is equal to the kinetic energy in A. So if the spring is stretched 10 millimeter, so X is equal to 10 times 10 power negative 3 meter, calculate the spring constant. Okay, so how to calculate the spring constant? So referring to the concept of energy stored in the spring is equal to the kinetic energy of the, referring to the energy stored in the spring that connected between the two carbon atom is equal to the kinetic energy of this model. So we can write down that the kinetic energy, which is 0.04, is equal to half kx square. Okay, and then x is equal to 10 times 10 power negative 3. You just need to substitute in the equation, and then you will get the answer, which is equal to the spring constant is equal to 800 Newton per meter. Okay, and now we go to the if you have any question, you can write down in the chat box. Okay, for question number 6, a 60-gram object is dropped from a height of 2 meter. After striking the floor, the object rebound vertically upward, losing 25% of its initial energy. During its first rebound, we need to calculate the initial velocity of the object and also the maximum height of the object. Okay, so referring to the information given, there are few hidden information. For example, because of the object is dropped from that height, so the initial velocity is equal to 0. Okay, and then when the rebound, the energy loss 25%, meaning that energy, referring to the principle of conservation of energy, the energy rebound energy is equal to 75% of initial energy. Okay, that's the meaning of losing 25% of initial energy. Maknanya the left energy is only 75%. So during its first rebound, okay, first rebound, because of the object may, when it is dropped, it can be rebound few times, right? So we just focus on the first rebound. So we need to calculate the initial velocity of the object. So to calculate, to understand the question, so this is the diagram that we can illustrate referring to the question. So we have the initial velocity, which is mgh, because of kinetic energy is zero when the ball drops at the height of 2 meter, and then rebound. Okay, we want to calculate the initial velocity of the object just after it rebound. Okay, so we know that the initial velocity is equal to mgh, and the concept of E rebound, which is equal to 0.75 E initial. So E rebound is referred to the kinetic energy of the object just after it rebound. Okay, just after it rebound, the kinetic energy is half mv square, which is equal to 0.75 mgh initial energy. And referring to the equation, we can cancel the mass to simplify, to make it simple calculation, and then we can calculate the initial velocity v. So you will get that initial velocity is equal to 5.42 meter per second minus 2. Okay, so that's the way how to calculate the initial velocity after the object is rebound, just after the object rebound. And for question B, you need to calculate the maximum height of the object. So for the maximum height of the object at the first rebound, okay, at the first rebound, where the energy loss 25%. So how high do the object can reach 2 meter like before? So we can calculate. So referring to the equation principle of conservation of energy, in this case, E rebound is equal to mgh, meaning that 100% energy after the rebound, which is the kinetic energy, is converted to the potential energy. So that potential energy will give the maximum height that the object can reach. Okay, in that case, same thing, we can cancel the mass. Okay, and then we just need to substitute the energy rebound, represent the kinetic energy just now, with the v that we have calculated, which is 5.42, and then we want to calculate the h max, substitute the g 9.81. You will get that the maximum height reached by the object is 1.5 meter. So is it acceptable? If you refer to the diagram, yes, because of 25% of energy loss, so the object cannot reach its initial height. It is only can reach 1.5 meter. Okay, so for question number 7, okay, for question number 7, a 0.02 kilogram ball bearing is placed at one end of a spring, and the spring is compressed by 20 millimeter as shown in the figure. So I hope that you understand the diagram. Actually, this is the rail, okay? The track of the ball. Okay. So initially, the ball placed at one end of the spring cause the spring to compress 20 millimeter. 0.4 Newton force will compress it 1.5 millimeter. So this is only statement that saying if the 0.4 Newton force exerted or compress the spring, the spring will compress 1.5 millimeter. So referring to the information given, so I have listed the information here. You want to calculate the energy stored in the spring. Okay, first we want to calculate the energy stored in the spring. So to calculate the energy stored in the spring, the equation is half kx squared. Okay, half kx squared. So if you refer to the information, we do not have the value for k, and we also cannot use equation of energy stored in the spring, which is u is equal to half fx, because of f here is a statement that saying if the 0.4 Newton forces exerted on the spring will extend or compress 1.5 millimeter. Because of that, we need to calculate the K first. So referring to the information here, we can calculate the K using the Hooke's law. Remember, you have learned Hooke's law during the SPM. So Hooke's law F is equal to Kx, and then substitute F from this statement, and you will get the K, which is the spring constant, is 267 Newton per meter. And because we use the same spring, okay, to compress by the ball, so we can use this spring constant, substitute in the equation, and you will get that the potential energy stored in the spring is equal to 5.34 times 10 power of negative 2 joule. Okay. And then question B, based on the work energy theorem, why does the ball maintain a constant horizontal velocity after being released? Meaning that the ball can move straightly on the track. Okay, so when you want to explain, you need to refer to the work energy theorem. So referring to the work energy theorem, first, which is W is equal to the change of kinetic energy. So work, we know that it is equal to F dot S. So what you supposed to can discuss. Okay, you can give the reason. First one is because of there's no friction. Okay, so no work done against friction because of actually because of there is no friction, meaning that it is a smooth surface. Okay, that's why the ball can move, maintain the constant horizontal velocity, no friction. Okay, no work done by the friction. And you also can say that there is no change in potential energy. So if no change in potential energy, because of the horizontal plane, okay, the ball move horizontally, so no change in potential energy. And you also can say that total energy is conserved, where when the K is constant, the velocity is also constant. That's why the ball can maintain a constant horizontal velocity after release, after being released. Okay, that's the reason why the ball can maintain a constant horizontal velocity. Okay. And for the question number C, if the ball then travel up a vertical frictionless circular track of radius 0.1 meter, calculate the ball speed at the highest point of the track. Okay, so if you look at the diagram, this is the track. Actually, this is the vertical frictionless circular track. Okay, here. So the ball will move at this track. Okay, and we need to calculate the speed at the highest point. So how we want to calculate the speed? So we will use the concept of principle of conservation of energy, which is stated that at any point on the track, the total energy is conserved. So in this case, when the ball at the top, so total energy at the top is equal to total energy stored in the spring, because total energy stored in the spring will convert it to the total energy at the top of the track. Okay, because of that, take a look at the energy at the top. We know that the ball will move at the top and at the certain position. So there are kinetic energy and potential energy at the top, gravitational potential energy, and this both energy is equal to the energy stored in the spring. Okay, because of the energy stored in the spring, so the ball can move and the move on the track and arrive at the vertical height. Okay, so we can calculate, we maybe we can substitute the value. Okay, so in this case we cannot cancel the m because of energy stored in the spring we have calculated earlier. So we just substitute the mass and also the mass and g, and also the top at the top, the height at the top, because of the radius of the curved track is 0.1. So the height is represent 2 times 0.1, or we can say 0.2. And if you calculate, you will get that the V is equal to 7.034 meter per second. Okay, and for question number 8, okay, question number 8 state that a pendulum with a string of length L equal to 22.2 meter is released from point A. So here is point A. Sorry. Determine the speed of the pendulum when it reached the lowest point. So how we want to calculate the speed at the lowest point? Okay, I just sketch back the figure given, where I label we can calculate the height, the h, from the level of position at point A. Okay, so we will get that here is h. The length of the string still L. Because of that, at this part, this is a triangle, right? So at this length, it is represented by L cos 50 degree. Okay, that's the extra information from the diagram. So to calculate the h, because of we need to know the change in height. So h is equal to initial length of string is L, so L minus with L cos 50 degrees. So you will get the h. So substitute the value, you get initially you get the h, which is 0.79 meter. So what can we do with this value for h? So from the principle of conservation of energy, E initial, which is at point A, is equal to E total energy final at the lowest point. So at the point A, the energy involved is mgh, because of when the pendulum arrives at point A, it will stop and then turn back to the lowest point. So only potential energy at the pendulum will have the potential energy at that point. And then final point at the lowest point, so it have the kinetic energy. So total potential energy is converted to the kinetic energy. And then because of the same pendulum, we can cancel the mass and you can substitute the value where the h at the point A is, we have calculated here, just substitute. And then you will get that the speed at the lowest point is equal to 3.94 meter per second. Okay, so meaning that the free body diagram, this is we can say it is not free body diagram, but you need to identify the h from the diagram given. So it is very important. Then you can get the value for v. Okay, now we have go live for 30 minutes. Okay, so we will take a break for the advertisement. Okay, and then we will come back. So take.
Berita baik untuk semua. Kini Akademi YouTuber memperkenalkan sistem mata gancaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus ganjaran hebat ini sekarang. Layari www.academyyoutuber.com untuk maklumat lanjut.
Okay, so before we continue, okay, welcome back everyone. So before we continue, I want to announce the third digit code for credit claim, and the third digit code is number 6. Okay, number 6. So please write down somewhere. All right. Okay, the third digit code is number 6. Now we will continue. All right. So we just finished discuss question number 8. Now we go to the question number 9. Okay. For question number 9, a sphere of mass 4 kg initially at rest slide along a smooth and curvy surface as shown. Calculate the potential energy of the sphere at point A and also the speed of the sphere as it passes point B. Okay, if you refer to the information given, this is the sphere with the mass of 4 kg. Initially at rest, so hidden information U is equal to 0 meter per second. And then from the figure, I just write down here, the height at the point A is 40 meter and the height at point B is 20 meter. Okay, now we want to calculate the potential energy of the sphere at point A. So we know that the potential energy is given by the equation of mgh, because of at point A, the object is still at rest, no kinetic energy yet because of the sphere is not moving. So referring to the potential energy equation, you need to substitute the mass, which is 4, g, and also the height at point A. 40, you will get that the potential energy of the sphere at point A is 1569.6 joule. Direct question, okay? And then for question B, the speed of the sphere as it passes point B. So you need to calculate the speed at this point. So we refer to the principle of conservation of mechanical energy because of at point B, the object is moving, the sphere is moving at the same time at that height. Okay, so for the principle of conservation of mechanical energy, it is involved the kinetic energy and also the potential energy at point B. So in this case, I just represent, I will refer initial energy is at point A and final energy at point B. Because of that, at point A, as I said, the sphere is at rest, no kinetic energy, only the potential energy. And at the point B, there is a kinetic energy and also potential energy given by that equation. And it is easy for us to cancel the mass first. Okay, no need. If you substitute also can, but it will shorten your time. Okay, if you just cancel the mass, and then when you substitute all the value given here, and do the that HB is 20 meter. So you can calculate the VB. With VB is equal to the speed of the sphere as it passes from B is 19.81 meter per second. Okay, 19.81 meter per second. So we use the principle of conservation of mechanical energy in this case. Now we go to question number 10. Okay, so for question number 10, figure 7 show a particle moving down a curved track with speed u at a height of 3 meter. Upon leaving the track, the particle travels straight up and reach a maximum height of 4 meter. By using the principle of conservation of energy and ignoring the friction and air resistance, determine the speed u. So referring to this question, don't confuse that this is the track or this is the curved track of the particle. And then when the particle moving down and leaving the track, so the particle will move until moving upward because of the track, the shape of the track, until reach 4 centimeter. Okay, sorry, 4. Here is 4 meter. Okay, 4 meter. Sorry, this here is supposed to be 4 meter. Okay, so I just differentiate the height, initial height, which is small h, 3 meter, and the height when the leaving the curved track is 4 meter, h, capital letters of h. And at that point, at the maximum height here, v is equal to 0. So to calculate the speed, we refer to the principle of conservation of energy. In this case, the principle of conservation of mechanical energy, because of the situation at both points consists of kinetic energy and also the potential energy. Okay, because of that, for the initial, because of the objects moving initially with the velocity u that we want to calculate, so we just need to cancel the m first. Okay, cancel the m, and then just substitute the value for g and h. So the first h is referring to the initial height, which is 3 meter, and then the final h is 4 meter. So that's only the difference when you substitute. And please calculate carefully. You will get that the speed initial speed of the particle when moving downward is 4.4 meter per second. And with this speed, the particle can leave the track until the height of 4 meter. Okay. So this is how, doesn't matter actually, because of you also can change to the here is 3 meter, right? Okay. Now we go to the question number 11. So for question number 11, a 2 kilogram stone is dropped from the top of 10 meter high building. Okay, mass of the stone is 2 kilogram. Is dropped, meaning that the initial velocity is 0. That's the hidden information. Okay, the height of the building is 10 meter. By using the principle of conservation of energy, calculate the kinetic energy of stone when it is at 0.4 meter above the ground, meaning that before the stone touched the ground. In the question, normally it state you need to refer to the principle of conservation of energy because of if you solve this question using kinematic equation also can. So it's specific for you to refer to the principle of conservation of energy to calculate the kinetic energy. So referring to the principle of conservation of energy, or we refer to the principle of conservation of mechanical energy because of kinetic energy and potential energy involved in this case, the motion and also the position, the height. So we can write down that initially when the object is at the height at the top of the building, half mu square plus mgh, and then at 4 meter above the ground, k is kinetic energy k final that we want to calculate plus with mgh at that point. So what you need to do, you can substitute in this case because we cannot cancel the m because here is the kinetic energy that we want to calculate at 4 meter above the ground. So when you substitute the value, u initially because it is dropped from the height. Initial velocity is equal to 0. mgh, this is h is the maximum height of the building, and then this is the height at the 4 meter above the ground. So if you calculate, you will get that the K is equal to 117.72 joule of kinetic energy when the stone located 4 meter above the ground. Okay. And then for question number 12, a jet engine developed a horizontal thrust of 30 kilonewton, meaning that this is the force, okay, because the unit is Newton, so thrust force. If the jet is flying at a velocity of 300 meter per second, calculate the horsepower developed. So what you want to calculate actually? It is quite confusing, right? Because the horsepower is actually the unit for the power. All right. So we want to calculate the power. All right. So how? So, if I'm not mistaken, question number 12 is involved the third part of this topic, which is about the power. So referring to the given information, we have the thrust force, we have the velocity of the jet, and also we want to calculate the power. So because of that, we can use the instantaneous power equation, which is ft dot v, and then of course because of the engine the velocity of the engine is of course same with the horizontal thrust force. So 30 for the thrust force times with 10 power of 3. 30 times 10 power of 3 because of 30 kilonewton. Okay, so 10 power of 3 times with V is equal to 300. So you will get the instantaneous power equal to 9 times 10 power of 6 watt. But the question want you to calculate in the horsepower. Okay, so we know that the relationship 1 horsepower is equal to 746 watt. Because of that, to calculate the instantaneous power in the horsepower, we just need to divide the value by 746, and you will get the instantaneous power is equal to 12,064 horsepower. Okay, this is a familiar question. Yeah, you need to change from watt to the horsepower. Now we go to the question number 13. For question number 13, a 2.5 kilogram block slide down a rough inclined plane of angle 20 degree with the horizontal at the constant speed u equal to 1.5 meter per second as shown. What you need to do is first, this is the previous topic. You need to sketch and label the forces acting on the block and calculate the rate of work done by the frictional force on the block. Okay, first, there is a few information which is stated that horizontal constant at a constant speed. So what is the hidden information for the constant speed? Even there is a value for that constant speed, but the hidden information is A is equal to 0. Okay, because of that, first we need to sketch and label the forces acting on the block. So this block is laid down on a rough inclined plane. Of course, there is a frictional force. exerted opposite direction of motion, opposite with the acceleration A. And then there's a normal force and also the weight. This is your free body diagram supposed to. And for the calculation later on, because of W is not located at the X or Y component, so we need to resolve the W to the WY and WX. Okay. But your basic free body diagram is represented by the forces of normal force, friction force, and also the weight. Okay, for question number B, calculate the rate of work done. Okay, rate of work done. What does it mean by? What you want to calculate actually for the rate of work done? So rate of work done is W per dt. Rate is dt. So it is actually you need to calculate the power. Rate of work done is represent the power, and you need to calculate the rate of work done by the frictional force. So power is equal to the F is referred to the frictional force times with the U. Okay, so how? If you look at the information, we have no value for F. Frictional force is not given to us. So first you need to calculate the frictional force. And to calculate the frictional force, you need to refer to your free body diagram, which is we have do a lot of practice in my previous tuition class. Yeah. So you can refer to the video. So at X component, total forces is equal to 0 because of the object is moving with the constant speed. A is equal to 0. And the forces exerted same direction with A is WX at the X component. So Wx minus F, because of F is in the opposite direction, equal to 0. And we can calculate the frictional force, which is equal to 8.72 Newton. So after we calculate the frictional force, we just need to substitute in the rate of work done or in the power, where the frictional force is 8.72. The initial velocity just now is 1.5. Not initial velocity, it is a constant speed. Sorry, constant speed, 1.5. So the answer for the rate of work done or the power is equal to 13.08 watt or joule per second. Okay? That's the how we apply we use the previous topic, which is about the forces, okay, free body diagram, to calculate the power. Okay. All right, for question number 14, a car of mass 2.1 times 10 power of 3 kilogram travel with an initial speed of 15 meter per second. If it is accelerate at the rate of 2.5 meter per second for 10 seconds, calculate the change in kinetic energy. Alright, referring to the information given, the mass is 2.1 kilo times 10 power of 3 kilogram. Speed is 15 meter per second, and acceleration is 2.5 in t10 seconds. Okay, so to calculate the change in kinetic energy, we refer to the change of kinetic energy is referred to the K final minus K initial. Okay, so half mv square minus u square. Our v is, we have no value for v. We need to calculate first because of U is given. We want to calculate the change in kinetic energy. So we need to calculate the V first. Referring to the information given, we can calculate the V, where the V is equal to 40 meter per second, and substitute in the equation. Substitute also the mass and also the U. You will get that the change in kinetic energy is 1.44 times 10 power of 6 joule. Okay, and to calculate the power of the car, we know that the power of the car is the rate of work done. Okay, so from the work energy theorem, we know that the work done is equal to the change of kinetic energy. And in A, we have calculated the change of kinetic energy for this case. Because of that, we just need to use that value. We can substitute in the equation, and we can calculate the average power, the power which is equal to 1.44 times 10 power of 5 watt. Okay, so this is the answer for the power of the car. Actually, this is referred to the average power because of the constant accelerate at the constant acceleration. Okay, now we go to the question number 15. So for question number 15, sorry, for your information, actually the question, I have, because we arranged the mid-semester test following the year, but when I discussed, I arranged the question following the topic. So it's easy for you to refer. The first part of the question revision is about work. Second part is about the energy, and the third part is about the power, relate to the power. Okay. Now take a look at the question number 15. A 650 kilogram leaf start from rest. Okay, hidden information, start from rest, u is equal to 0. It move upward for 3 seconds with a constant acceleration. So A is constant and reach its final speed of 1.75 meter per second. So calculate the force exerted by the leaf motor and determine the instantaneous power in the horsepower of the leaf motor when t is equal to 3 seconds. Okay, first we want to calculate the force exerted by the leaf motor. Of course, when involve the force, it is very easy for us to sketch the free body diagram so that we can imagine the forces exerted on the object, in this case on the leaf. So F motor is exerted upward because of it will lift the it will lift it will force exerted to lift the motor. Okay, the lift motor, and then the weight is exerted downward, and we know that the lift is moving upward. Okay, so to calculate the force exerted by the lift motor, so we refer to the Newton's second law. Sum of forces is equal to ma, and at the y component here is the y component of forces. So for at y component, up because it is moving upward, so F motor minus with the weight is equal to ma. Okay, moving with the acceleration a. So we can calculate the force exerted by the lift motor from the equation of F motor equal to ma plus mg. But in this case, we have no value of a. So we need to calculate first the value for a, constant acceleration. So referring to the info here, we can calculate, we get the A is equal to 0.583 meter per second. So we just substitute, after we calculate, just substitute inside the equation. You will get that the force exerted by the leaf motor is 6.76 times 10 power of 3 Newton. Okay, that's the first part. For the second part, you need to determine the instantaneous power in the horsepower. So for the instantaneous power, we know that the power the instantaneous power is equal to F motor dot V. So F motor we have calculated earlier, and the V is 1.75 meter per second. Just need to substitute in the equation, and you will get that the instantaneous power in the watt unit. Okay, which is 11.83 times 10 power of 3 watt. The question want you to calculate the instantaneous power in the horsepower. So we do the same thing. 1 horsepower we know equal to 746 watt. Because of that, we need to divide the watt by 746. You will get that the instantaneous power in the horsepower unit is 15.86 horsepower. Okay. Now we go to the last question. Oh, we are at the last question. Very good. So we finished quite early. So I hope that you can do the revision. You can try to do yourself, and then you can check with your solution with the video. Actually, this topic is because of work, energy, and power is a scalar quantity. So if you look at the solution, the trick is less trick to answer, but you need to understand all the concept that relate. So I think that's it for today's class. I wish you thank you for watching, and I wish you good luck, all the best. Don't forget to leave a comment in my video so that I can improve my next presentation. Okay, so we have finished now. Maybe the times that you are waiting for, we have reached at the end of today's class lesson. So congratulations to those who are able to follow our lesson from the beginning till the end. So before we end our session for today, I want to announce the 2-digit code for the credit claim. So please listen carefully. The last 2-digit code is number 6 and 6, which is 66. Okay, 66. So all of you, thank you so much for watching this video, and please click the subscribe button and activate the icon bell so that you will not miss the next class. Then if you find that the lesson was beneficial, click like and share to your friends on your social media. Spread and share the goodness. Once complete, type done on the chat box, and the certificate link will be given as a token of appreciation for your dedication in joining the free online tuition class. So I will put the link. Okay, I will put the certificate link and also the credit claim. Yeah, the link for the credit claim. Wait, yeah. So link credit. Okay. So that's the link credit and the CJ. Okay, you can fill in the link CJ. Okay, and if you okay, this is the email for EDD. Witness. Okay, I will post all the important link. Okay. So please take note. I have post all the links in the chat box. Okay. So take note that the link will end half an hour after this live. Make sure that you use the ED email or MOE email to log in. So incorrect email will not be entertained. And if you not have one, you can apply the link. Okay, the EDD email. So the link is given in the chat box too. If you wish to get more information on the online classes, you can go to the academyyoutuber.com, and those haven't joined the EDD Junior Telegram, please do so. So once again, I would like to thank all of you for joining today's class. You are awesome. Feel free to share this free tuition class to your friends and teachers all over Malaysia. This is collective effort from the teachers throughout Malaysia for all the students throughout the country. Thank you for being a YouTuber Academy supporter too. So I think that's all for now. See you in another lesson. So remember the hashtag bermula percuma, selamanya percuma, and stay safe till we'll meet again next week. Same day and same time. Okay, bye.
Wow, banyaknya hadiah menarik menanti anda. Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma. Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang. Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.